In this video, we'll build a real-time ride analytics project from scratch using Databricks. I'll walk you through the complete architecture and we'll use the Databricks free edition so anyone can follow along and implement it. A lot of people are not very clear on why Spark declarative pipelines are needed, so I'll break that down in detail, covering the benefits of both streaming and batch workloads. This is one part you'll definitely enjoy. You won't just watch, you'll actually build the entire project yourself, starting from setting up your GitHub repo all the way to completing the final solution. We'll create the full Spark declarative pipeline step by step with a strong focus on hands on building rather than just theory and concepts. Along the way, we'll build both streaming table and materialized views required for the project. Then comes the fun part. We'll create a dashboard from scratch using Databricks AI BI. Finally, we'll wrap things up by deploying and automating the entire project, including the dashboard using DApp and GitHub Actions. I genuinely enjoyed working on this project and I'm confident that you'll learn a lot from it too. So, see you in the video.
So you think that you work for a operations team for ride sharing app, something like Uber, Ola. So let's take an example of India. From Uber or Ola, you do have operations all over the country, right? So for example, for our example, we'll take maybe examples of all the metro cities. So as an operations team, that whenever you're working, you have to take care of a lot of KPIs in place. You have to know, like, is there any cancellation going on? If the cancellation is going up, some users are complaining about they are not getting the ride. So there's a lot of KPI to track, and I have built a dashboard to show you that as an operations team how these dashboards will be useful. So let's check the dashboard first. So this is the dashboard that is created on Databricks AI BI. So I'm able to see like how much revenue I'm doing for, and what is the completed rides. I see the cancellation rate, that is 27.5%. This is still less than 30%, so that is good for now. I do see active drivers. I see the average fare, and in this particular chart I can see that what's the revenue trend is happening for the last 60 minutes. So every minute I'll be getting the revenue numbers, so this is very important for you to see, right? I can also see the ride mix by status. I see that this many has been completed. I see 2.6% is no driver found. I can also see that 3% of the rides are cancelled by driver. That is one of the concerning thing that you can check on. And I can also see the what is my revenue by city for all the cities that I'm doing the analysis currently. I can see what is the top 10 revenue zones. I see that if I short it by revenue, I see that Delhi is doing really well and the average fare is also very fair, right? But now I want to do even deep dive into the operation stuff now, right? So for example, I can see the what's the cancellation reasons by city. So for example, if I just select the Hyderabad on the right, I'll see what's the cancellation for 785 rides are they're find the users are saying they found the alternative transport. Some folks have changed their mind. I see ride taking too long. That is one of the concerning team. So I can talk to my operations team. I can see like why the riders are taking too much time. Is it due to traffic or is it due to negligence, right? I see book by mistake, driver too far. So this is also a very concerning thing, that why if I'm booking something, why is it getting assigned to drivers who are very far, right? So on the for the operations team, these KPIs are really important. I have one more chart, that is what is the demand and cancellation risk. So for example, if I do the shorting on cancellations, I see that for Mumbai area, that is Powai, in that is zone is MUMZ2, I see there are 649 rides, and from that 205 rides are getting cancelled. That is 31%. That is a lot of concerns for the operations team and also like for the whole company, right? So as a operations team, I can talk to folks who are working on the ground. They can let me know like why is it happening currently. I can talk to them, I can fix few things, right? And all this KPI, this cannot be on batch wise, right? I want this data as soon as I can. So I can talk about this is the live data tracking you're doing, or maybe real time or near real time. because if we get this like every half an hour or 1 hour, your operations team won't have much time to react to it, right? So if I get this data in real time, I can take actions on top of it, right? And all these things are built on Databricks, and I'm really excited to talk about this particular project. So without further ado, I'll go off the screen and I'll explain you how did I build this on Databricks. Let's talk about the architecture for this project. We'll be using the Databricks free edition, right? So if you do not have any account yet, just search for Databricks free edition and the first link should take you to sign up page. So you can sign up for free edition. You can either use Google account or Microsoft account to log into it, and it's very easy to sign it up. And this is totally free, right? So if you see, Databricks free edition is used for learn professional data tools for the free. So everything that you need for this course is freely available in Databricks free edition, right? So once that is done, you can start creating the project. And this is how the structure for the and this is how the architecture for the project will look like. First, we'll have an ingestion stage. So this is basically to simulate how for any ride app or ride analytics project, the data that you want will be simulate that data here. So we'll be simulating as a Python job. So we'll be also scheduling this as a workflow. What it does, it writes JSON files into a UC volume. So we'll be setting up the UC volume, and this job will be creating all those JSON files here. This is to simulate the data. So either you can also use Kafka here. So you can use a Kafka as a broker, and you can use a Python job to write the data into Kafka. From Kafka, you should be able to go to Bronze. But I did not want to do that complicated setup for this demo, because this is more like writing the job, right? So, but if you want to check it, I do have a Spark structure streaming with Kafka playlist, and if you're interested to how to work with Kafka, you can check that. So I had used Kafka Confluent Cloud with Kafka structure streaming, right? Then we'll have different stages: bronze, silver, gold. In bronze, we'll be using Autoloader cloud files to load the data from UC volume to a bronze write event. So this will be a streaming table, and whatever transformation that we are doing, we'll be using the Spark declarative pipelines. And I know that some people have love and hate relationship with Spark declarative pipelines, but I can promise you, once you complete this video, you'll love Spark declarative pipeline, and you'll stop writing vanilla Spark. You will just use Spark declarative pipeline. That I can promise you, right? So this is what the bronze table will be there, and then we'll be creating one table on silver, that is silver write event. This will have some filters around the bronze, and we'll also add some expectation. Expectation is nothing but these are the data quality rules or checks that you can add. So as we go from one stage to another stage, the quality of the data should improve, right? So I'll be showcasing how to add expectations. Then at the end, on the gold layer, for the reporting purpose, we'll be creating lot of materialized views. I'll be talking about this in detail. What is this? What is the benefit of materialized views, overviews, and all that stuff, right? So we'll be creating views like gold cancellation analysis, gold live KPIs, gold pickup demand. Because why we want to materialize this? Because in that case, your reporting that we'll be doing with AI BI dashboards, whatever you just saw in the starting, so it will be quite faster, right? So I'll be talking about like how do you create all this materialized views and how do you use that in AI BI dashboard. So this will be our inbuilt visualization tool in Databricks. So I hope this makes sense. Then let's continue. So all the code required for this project exists in this particular repo, and I'll be adding this repo link in the video description. So what you do is either you fork it in your own repo, or you can just use this code HTTPS, because this is a public repo, and we'll be creating a GitHub Git folder in Databricks workspace too, because we do have some artifacts that we want to use to do our project. So I'm in my free edition. So this is the Databricks free edition. I'll go to workspace first, and inside my user I'll do create Git folder. This is to connect to your GitHub, and you can work on those files here, right? So do a git folder, add it. You can just give some name, right? Write analytics project, right? This will create a git folder for that. So I am inside this, and this is where all your code exists here. You should be having this question in your mind that why not use a Spark structure streaming for this real-time processing, or for this batch processing? Why not use vanilla Spark in Databricks, right? To showcase you that, I have created two notebook. That is, you go to source, you go to demo. Let me just pull the changes. So you'll be finding two notebooks. One, I have tried to explain what is the benefit of Spark declarative pipelines for both, that is streaming, for using streaming with Spark declarative pipelines, or using materialized view with Spark declarative pipelines, right? Let me go to first streaming this notebook. So I want to show you like what is the benefit of declarative versus manual Spark structure streaming. So if you're not aware of that, I do have a Spark structure streaming tutorial with Kafka. So you guys can check for this particular playlist in my channel. But this talks about in detail how do you work with near real-time data or real-time data with Spark structure streaming, right? Because I think before you know the Spark declarative pipeline, you should be aware of how Spark structure streaming works, because Spark declarative pipelines is kind of abstraction on top of this, so you don't have to handle a lot of things here, right? So I'll really recommend you to go through this particular playlist. This is highly recommended, but you can always do this video without watching this particular playlist. But there are some basic you might be missing. But I'll highly recommend you to go to this playlist and watch it. Just think about that. I want to do this in a manual way, so I do have some data around it, and I want to create some Spark structure streaming on top of it, right? So the idea for Spark structure streaming, it you create the schema around it, and suppose you want to create a branch query, right? So you are writing a Spark read stream with autoloader functionality. You have to create a checkpoint here, right? So this is something that you have to manage, right? This is exactly where your business logic will come into picture. So I am doing some cleaning, then I'm writing it. Even if some error happens in any batch, you have to handle it yourself. So your Spark structure streaming will not help you to do that, right? Then at the end, once you do all the transformation, you have to write the data here. So you have to write all this code for each batch. You have to provide checkpoint location, and even these things you have to manage it, right? And there are some boilerplate codes that you have to do, right, to make this as a continuous pipeline. So what we did for this, right? There are a lot of responsibilities when you are doing this on Spark structure streaming. Something like you have to do the checkpoint management. So you have to create the paths, ensure that they don't corrupt on restart. You have to take care of schema enforcement. You have to do error handling for all the batches. So basically try accept it every for each batch. Retries on failure. If any failure happens, you have to rerun the whole job, reapply logic. Lineage, there is no lineage available, right? So if you create multiple Spark structure streaming job, there are no lineage happens, right? Which runs at what time, what's the dependency between that? You will not get that in Spark structure streaming. There are no ways of inbuilt monitoring tool. Then the table registration, yeah, register in Unity catalog separately. Data quality metrics, you have to write a lot of jobs to do it. You do not have any existing way to track data quality. And just think about, and this is just two tables, right? So think about, like, if we have like 10 to 15 pipelines, you have to take care of all these things by yourself, and there will be a lot of issues happening around it, right? So there should be a better way to handle it. And from my perspective, whenever I've started learning Spark declarative pipelines, I thought about these things, right? Like creating this query and doing this termination. These things looks like a boiler code to me, right? This should be handled by Databricks or Spark itself. I don't need it, right? So all I have to care about, like how I want to, suppose this is important, how do I want to write it, read it, and how do I want to transform the data. So this is the user case, right? And that's where the declarative things come into picture, right? Now let's see, I'll be talking about this in details, how do you write Spark declarative pipeline, but let me show you guys you that the same pipeline, if we write in Spark declarative, how do we write it? First, this is similar, right? You have to define a schema. Then we are decorating this function as a DP table. So there is something called as a streaming table. So you just return it. So what you do is like this remains the same. So you are reading it and you are returning it. That means that you are just telling that, okay, I want this to be read, but you figure out how do you read it, how do you write this as a table, how do you materialize this, and this is something that will be taken care by Spark declarative pipelines. Similarly, you see for the silver ride events, basically I'm reading the same streaming table. So whatever this table that I've already created, I'm reading that table, I'm adding few new column, but I'm also able to add a lot of quality checks here, right? This we call it expectation. So don't worry about all this, I'll be talking this in detail, but think that I haven't written any checkpointing, I haven't done like how do you materialize this one. I have written what I want, and Spark declarative pipelines figure out how do you materialize this, right? So from this stuff to this, it's so simple to write, right? You just write your business logic and Spark declarative pipelines take care of it. I think this is a big distinction between these two, and there are a lot of optimization happens if you use Spark declarative pipeline. Some of them are that what Spark declarative pipelines gave you for free, right? So you do not have to do any checkpoint management. So this is the automatic schema enforcement. If you want to do something like that, you have to write your own filter code, but here you can define like expect or drop to do any schema enforcement. Violation tracking, if something is violated like data quality checks, you have to log it yourself, but we'll see like while we run this Spark declarative pipeline, this is like a built-in metrics per rule, right? Retry on failure, rerun job manually, but in Spark declarative pipeline, it is auto retry with back off. Data lineage gap, this is not available, but here you have a visual tag in UI. I'll be showcasing that how the lineage comes, right? Unity catalog registration, you are creating a different write statement, right? Like how do you want to write it, like this one, right? But here you do not define it. This will be taken care by online, right? Pipeline monitoring, parse logs manually, but you will get event log plus UI. Adding a new table means you have to add a new query plus checkpointing per, then you have to wire it basically, right? This adds a lot of boilerplate code. But adding a new table in Spark declarative pipeline just is like adding a decorator as db.table, something like this, right? So I have defined this is I need a table and I need this as a table to be created. This is all it takes, right? So I hope this makes sense regarding why for any structure streaming or for any streaming job, what are the benefits of Spark declarative pipelines over Spark structure streaming, right? And there is one more notebook I've created, that is batch aggregations. So this talks about the benefits of Spark declarative pipelines for batch processing, right? So let's think about that, right? So I'll be creating some aggregated table now. Now my job is to, whenever there are new data coming in the base tables or on some tables, I want to keep that aggregation table fresh, right? So there is basically two way to do it. One is a manual way. So basically you have to write a delta table plus merge it yourself every time. So basically using merge statement, you have to update this if any incremental data comes. And there is a materialized view way. So basically this is a very simpler way to define incremental data. So you declare the query once and let Databricks handle the rest. So whenever there are new data is coming up, Materialized view will take care of refreshing it by themselves, right? To do this, will be running everything on serverless because this is a serverless workspace. So So to showcase you that, let's create a schema that this is the workspace. So if you're not aware, when you create some workspace in free edition, the workspace name comes as workspace. And similarly, if you check on the catalog, you'll also have a catalog called as workspace, right? So this will be created by default, so you can use that to create your schema. So I'm creating a schema, then I'm this is just to drop any previously created table, and then I'm creating this table as orders. So the table is created. I'll just in some records into the table. So I do have records for 6 orders across 4 categories, and order 005 is cancelled. So we only want deliver orders in our aggregation. So we'll be adding some filters around it, right? So let me just read this data to showcase you the data. How does it look like, right? So I have all the data here. Now I want to create some aggregation first, right? So first the idea is the create the aggregated table and seed it. So this is the aggregated table, which is category, total orders, total revenue, average enter, and I'm inserting the data here after selecting this aggregation. So the base table that we have just created, so this is the base table, right? So we are creating a select category, count a star as total orders, sum of amount as total revenue, and we are creating an average for average order value, and we are only selecting the orders which are not delivered yet, right? So this will be the aggregation for that. So if I just run this, and I can select the records, so I see 3 categories and I see all the aggregation that is calculated. Now let's see, like if I get new orders, right? So suppose this is the base table, so I'm inserting 3 new records here. Now how do you once this record comes, how do you recalculate the aggregations, right? Either you recalculate the whole thing and replace the whole table, but that's not the correct approach, right? So you have to incrementally update this table, right? To do that, we basically create a merge statement, right? So we create that, okay, merge into this particular category table, right? Using what's the base table. Base table is just having that aggregation. Then if the targets and the source category matching, in that case you update all the aggregation. If the categories are not matching, then you insert all the data, right? This is the classic merge statement that we do. So we can just run this. Then I see that number of rows affected is 3, number of updated rows is 3. So the merge is working. Then I can just select the record. So this is absolutely work. This is how the batch queries work, right? But in that case it works, but you own everything: writing the merge, scheduling it, handling errors, one merge per aggregated table. So if you have a lot of aggregation tables and if you have a lot of incrementalization you want to do, you have to create all this merge statement by yourself. And this is a very common pattern in any data transformation job, right? So either you stream the data like what we did here, or you do some incrementalization, incremental data loading, right? So that's why this is why the materialized view will help you, right? So materialized view is very simple. So for first, what we do is like this: creating a materialized view does not work on serverless compute. So you have to use the SQL warehouse that you get by default. So you choose the serverless starter warehouse. Once you do that, creating a materialized view is very simple. All you do is like create or replace materialized view. You give the view name and what is the aggregation that you want, right? Basically whatever aggregation you want, you just create this, right? So this is how you create the materialized view. So you'll get a message like the operation was successfully executed. Now you can query the data, and this is not a view, right? So this will materialize the data. So view is basically like you create a view and you do a select statement. To every time you read it, it will recalculate the data, right? But the idea of materialized view is you materialize everything. So it will be stored in a physical storage, right? Something like, suppose I want to select the data from here and this result is already pre-computed, so it will be very faster, right? So it is not recomputing the result, it is already persisted the data. Now if I'm adding new rows to the base table, for example I'm adding order values here. Now I've inserted 3 records, but in this case I do not have to write any merge statement because materialized view takes care of incrementalization, right? So all you have to do is like just do this command, that refresh materialized view, give the materialized view name, and this will take care of doing this incrementalization. So whatever the merge command that you did, Databricks or Spark Declarative Pipelines will take care of like what's the best strategy to do this merge operation, and it will take care of it. So you don't have to do it by yourself. Once this is done, you can always read the data. So this is the materialization you get. And one important thing for you to notice whenever you're creating any materialized view like this, so if I just duplicate this and if I showcase you this particular view in the catalog, so I'll go to catalog, I'll select this, and this will say that this is a materialized view, right? And what happens is if you go to details, sorry, you go to overview, you'll see that it is showing as a current refresh status. So if you see refresh details, and it will open a Spark Declarative Pipeline. So whenever you create any materialized view that is outside of any Spark Declarative Pipelines, it create a Spark Declarative Pipeline by himself, right? And this is the materialized view, and it will say that incrementalization is incremental, means it is able to do incremental loading for it, right? So don't worry about all this, like what is the pipeline is all about and how this is done, but this is just a quick tip for you or quick note for you that whenever you're creating some materialized view like this, you create a pipeline for it that takes care of refreshing. So the idea is whenever you do something like refresh, it will start that pipeline and it will take care of incrementalization, right? I hope that this makes sense. So what did we achieve? That if you are doing the who writes the refresh logic, basically you write it if you are doing this manually, right? But if you are using materialized view, database takes care of doing that logic for you. Who should you schedule this? You have to create some job or cron to do it, but database take care of it, right? So if there are if the case is handling new categories, you have to do when not match, but this is done automatically. Handle deletes in sources, you have to add extra logic, but this is automatic in materialized view. One refresh for all tables, one merge per all, but you can add a one refresh in materialized view. I'll be talking about all this. And lineage tracking is, there is no lineage tracking if you are not using materialized view, but we'll see like how this is built in materialized view. Now the question is how Databricks or how the Databricks engine or the Spark Declarative Pipeline engine chooses the refresh strategy, right? So there are some ways that it is not able to refresh this incrementally, right? So in that case, there will be a full recompute happens, right? So there could be some non-incremental queries. Example, if we're doing a global aggregation with no partition key, that means it has to do a full recompute. So this in this way that this recomputes the entire materialized view from scratch, right? But suppose you have some partition override, right? You are doing some partition override. In that case, MB is partition and only some source partition change. So what it does, it rewrites only the effective partitions. So suppose you are having a query that just touches only one partition. Suppose you have a order group by keys for one country, and if there are new country data is coming, then it will just change that particular partition, right? In that case, it can do partition override. There can be something like you only have append only source plus aggregation with a grouping key, then in that case it can do a merge new aggregate delta into existing records, right? So this is something that materialized view will take care of. And if there are no data that is coming, so even if you refresh the materialized view, it will not do anything, right? So the benefits of this is you never write the logic, you declare the query, The engine picks the strategy at a runtime based on delta lake change tracking, right? So depending upon how the delta is changing, the materialized view engine or the Spark declarative pipeline engine will take care of how do you incrementalize it, right? So I hope that this gives you a view of how powerful the Spark declarative pipeline is. So you declare the materialized view once, and everything else is taken care by Databricks and Spark declarative pipelines, right? I hope this is useful, because I wanted to showcase you that, because I see a lot of confusion happens in the market. I have seen in over the LinkedIn that people are not able to understand that how do you do that. But knowing that what is the benefit of using Spark declarative pipelines over Spark structure streaming really gives you that confidence. Okay, I want to use this, right? You see all the benefits here, but whenever I'm creating the project, you will see a lot more benefits of it, and I promise you'll know, and I promise you'll never go back to writing Spark structure streaming or batch queries, right? So with this, let's go to the next section. So I'm inside the Git folder that we created previously. Now we're gonna need some setting up to do, right? So to do that, I have already created some notebooks. So go to source and go to setup. You'll find a notebook as 00 setup, and this is where we'll be doing all the setup. So first, we have the catalog, that is workspace, because we're gonna have this as a catalog present here, and if you do have some other catalog, just replace it here. And we're gonna create a schema called as real time. So basically you can first, the serverless should run. Okay, first let's run this particular cell, then we are using a use catalog, and then we'll be creating the schema in that particular catalog, right? So the schema is created. Now we're gonna need some volume. So first we'll be creating some checkpoint volume, and also we'll create the landing volume. So if you remember our architecture, we had a UC volume in place, right? So we're basically creating, so this is the volume that we are creating. So go back to the notebook, so you can just run this. So basically we are doing one for checkpoint and another is for landing. This is where we'll be landing our JSON files, and this is for checkpoint location if we're gonna need that, right? And then you can just verify if the schemas is created. So you can run this. I have already did some changes here, so I do see a lot more schemas, but you should only see the real-time schema that you have just created, right? So this is the setup that is done. Now let's if I see the architecture, let's create the simulation Python job, right, which write this JSON file to the UC volume, because UC volume is created now let's create the job. Now let's go back to the workspace, go back to, so it should be inside the source. Inside the source you should see a simulator folder. In simulator you do have a write simulator notebook. So this notebook takes care of creating those events, right? So I'm just creating like for Bangalore, Mumbai, Delhi, Chennai and Hyderabad. What are the codes, what are the zones, what is the area? This is just some Python code which creates this events, and the event looked like something like this, right, with some random values and all that. This is just the fake data that you are creating, right? So you can just run this simulation to see how this data is created. Let me run this whole thing. So this is started, and this has started writing the data to the volume. So batch size is 15 writes, but every 5 seconds I'm creating a batch, I'm writing this data. I'm now writing this as a write underscore, this is today date, and there is timestamp, and this is the file number. So you see different files are getting written to that particular folder, like 005, 006, and that is running for every 5 seconds. To check that, let's check the volume. So I'll go to the path schema is real time. So let me go to, let's duplicate this one. I'll go to the Unity Catalog Explorer, and this is the workspace. You do have real-time schema, and you will see there is volume created, right? And this is the landing volume that's there, and there you see there are different JSON files, right? So let's open Catalog Explorer. So every 5 seconds you have different JSON lines. So let me just download one of the file to showcase you that. So let me download this. So I open that in VS Code, and this is how it looks like. These are different JSON. So you see that for each file you have 15 events which has some records, write ID, event time, another thing. So just to see this properly, you can just copy this whole copy one line, and there in internet there should be some JSON formatter should be there, right? So let me go to this one, let me paste this. I'll do like convert, right? Or no, sorry, I have to do validate. Oh, I have to do format, right? Format beautify. So this is how the data is looking like. You have a write ID, you have an event time when this got generated. What is the status right now? The status is no driver found, city is Chennai, pickup area. You have some numbers around it. What's the distance kilometer, what's the payment method, what is the cancellation reason, high demand surge, what is the zone ID, is it is peak hour or false hour, right? So you have something like this. So you see different status are there, like no driver found, cancelled by user, completed. You'll see like cancelled by driver and all that, right? So that's the total idea for this. So now you have the JSON notebook that is running, but to do it better, right now we are just running it directly, but better is that we create a node lake flow jobs for it, right? So we call it workflow, you can call it workflow or job to schedule it. Let me stop this. I'll go to jobs and pipeline, and I'll create a job which is to orchestrate notebooks, pipelines, queries and more, right? So I'll create a job, and let me name this as a run simulator job, right? And this will be a notebook task. So you should see a run in notebook. Once this is done, this you can name this as a simulator task, right? And this is a type of notebook. This presents it to workspace. You can select the workspace path. So it should be there in Ride Analytics project, source, simulator, and this is the Ride simulator, right? This is all we need, and this will be running. This is a serverless compute, and we do not want to, like, you can always select performance optimized, right? But I think in free edition it is disabled, I guess. Yeah, I think this is not enabled in this, right? So this is all you need. Then create a task. This we can just run it according to when I need. So I see that this is run, and now I can run this. So this will start, and this will start writing the data. So whenever we want to start the simulator job, we can come to this jobs and pipeline and just run the simulation job, right? So in this section, as this particular repo will have all the artifacts that you're gonna need for this project, but in this particular video I'd like you to do very hands-on, right? So I want you to create new repos. I want you to follow me whenever I'm doing something. Do it in your workspace so that you'll have more idea around how to do that, right? So for that, let's create a new repo, right? And we'll be working on that repo together, and we'll try to do everything from scratch, right? So I'll create a new repo. I'll go back, I'll go to repo, I'll create a new repo here. Maybe I mean write analytics project from scratch, right? So this is fine, and this should be good with public, right? And maybe I can add some Python, and the license could be MIT license. And let's create this repo. Once this is done, to the HTTPS, just copy this clipboard. Let's go to our workspace. So this is my workspace. I'll go to my user. I'll create one more Git folder, right? So this will be empty project, but we'll start creating our artifacts inside this. So this is my project, and This will be a totally newer project, and we'll start creating our stuff here. Now let me show you how do you create a Spark declarative pipeline. My idea of explaining Spark declarative pipeline is I'll showcase you like how do you do something, then we'll talk about some of the concept. Because if you just go about theory, I think that really confuses some of the folks. There are a lot of newer things that is available in Spark declarative pipelines, but I have thought about a different way of teaching Spark declarative pipelines. But let me know in the comment section if this is helpful for you. Okay, so I'll go to jobs and pipeline, and this is how you create a Spark declarative pipeline. You see that it talks about ETL pipeline, build ETL pipeline using SQL and Python. Click this, and I can name this as a ride analytics pipeline, or maybe name this as a SDP, right? So Spark declarative pipelines. I want to select the catalog. So this is where you select the default catalog where you want to push your data. So this is the workspace. And what is the schema? My schema is real time, and Lakeflow pipelines editor should be on. Right now what we'll do is like we'll use the add existing assets, right? So we have to choose two folder. One is pipeline root folder, and what is the source code. To pipeline root folder is something whichever project that we just created, right? So you see that we created something like this, right? Write analytic project from scratch. We'll use this, and the source code path is where exactly we'll be writing our transformations, right? Like the actual data Spark declarative pipelines code, right? So I'll go again, maybe I'll choose this, and I think we need to create a folder first, so I can name this as a transformations. So this is where our transformation folder will be there, and we'll be doing, maybe we'll create one more folder that is called as explorations. So exploration is basically if you want to check some data, you can create some notebook inside it, but that will not be used to create the lineage for your pipeline, right? I'll be talking about what is that, right? So let me create this two folder, but for asset I'll select the transformation and I'll do a select, right? Now this is all good. So I've created two folder, one is pipeline root and what is the source code, right? I'll do this. So this is how it will come. Like this is a newer file editor that you get. Think about this is the editor for creating your ETL pipeline. So this is the two folder that we created, and you see that it will marked as a this is a pipeline source. So whatever code we create, that will come here, right? And you will see that you can see all files here, so that's not required for you, but I'll not showcase you all the option here. We'll start one by one, and I'll start explaining you how you do that, right? Now let's start creating our pipeline. So let me go back to the architecture, and so we created the UC volume, we created the job which takes care of writing the data to the UC volume. Now let's create this particular streaming table which reads the data from UC volume using cloud files and write it to the as a streaming table. So in Spark declarative pipeline, basically you have streaming table, that is the continuous writing of data, and you have something called as materialized view, right? So let's start creating this. So let me go back to the browser to the Lakeflow pipeline. We can do the namings like bronze, silver, and then gold. So let me create a file called as, we can create this files in both Python and SQL, but my preference will be Python for this particular video, but you can do the same thing in SQL, but only the syntax is different, right? So I'll name this as a bronze.py. So I really appreciate that you watch the video once and then try to do this from your end, so that you'll get the idea. If you're stuck somewhere, let me know in the comment section, or you can always ask Genie. So right, in Genie you can ask him to create some files or debug it for you, right? So you can click on this Genie and you can start asking the question, right? So first thing first, we're gonna need some of the inputs, like there is from PySpark you have something called as pipelines. So this is basically the declarative pipelines that you are doing. Then I'll do some imports, like from PySpark you need some functions, right? So, and from SQL types, you're gonna need some schema types, right? So this is required because we want to get the data types in place, right? Then we're gonna need something called as landing path, because this data will come from a UC volume. So let's do something called as landing maybe path, right? And this is something that should be configured, right? Like this should not be hard coded here, but because of that, so what we do is in Spark declarative pipeline, you can use Spark configuration to pass this as a variable, right? So you can get this variable like spark.conf.get, and you can give some name like landing, maybe landing volume path, correct? Then how do you set this part? You can go to settings for this particular pipeline, and you get option called as configurations, right? This is where you will be adding the key value pair, and this is the key, and the path will be the volume that you just created, right? In the setup, this is the volume path that you created. So it is like volumes, workspace, real time, and landing, because from here we want to get the data. So I'll just pass this here, I'll save it. Now this configuration is set, then we are good to go. Now as this is an autoloader, so we'll be passing the schema, right? So let me copy the schema for this. So this is a struct type, and you have all the struct field which is expected, right? So we have seen the JSON schema. This is how the JSON schema looks like, right? Now let's define the streaming table now. So this will be, now let me create a function called as, maybe I'll name this as define branch write events, right? This is the function that I'll be creating. Now what I want from this, right? I want this as a spark dot read stream. So this is how you will be reading the streaming table, right? Think about, this is the autoloader that you have, right? Then what is the format is, this should be cloud files, right? So this is the autoloader files that you have. And what's the option on, you have to pass some of the options, like option as, because the format for the cloud file is cloud files dot format. The format for this is JSON, so you're passing this one, and then you pass the schema. So schema is write underscore schema. Then from where you want to load the data, you want to load the data from, this is the landing path, right? And we'll be adding one new column, that is, this is the column that we need. So once this data comes, we want to get some metadata around it, like when the data got ingested, right? So we can use ingest time dot current timestamp, right? So this is all I need. So this is my business logic, right? I want to read this data from this particular path. Now how do I materialize this? I want to materialize this as a streaming table. To do that, this is very simple. All you have to do is dp dot table. So this is, we already did that. Now you can pass a lot of parameter, like if you see that this is already suggesting few things, that you can give the name, right? This is a branch write table, so all the materialized table will be created as branch write events, right? If you do not give this, then it will take the function name as table name, so the streaming table will name this as this one. But if you want to override this, you can give this a different name. You can add description here. Also you can add something called as table properties, and it takes a lot more parameters here, right? So I can add some parameters like table properties, the quality is branch. So this is all it takes. Now you see that I haven't defined any checkpoints, I haven't defined any other details. All I did was what I want, and how do I want to materialize this. I want to materialize this as a streaming table. That's all it needs to create this as a streaming table. So I'll do a dry run. So dry run is basically to check if all definition types and references in this pipeline without creating or updating any table. So we'll not create this tables, but we'll just check if all the syntax are correct, if semantically this is correct or not. Let's run it as a dry run. Okay, I'm not sure if this accept description. Let me remove this. Let's do a dry run. That's why this dry run is very important. You see that this table name is created. This is the streaming table name. Now you can do a run. To run this, you can either do like run pipeline or run pipeline the full table refresh, right? So full table refresh, if you want to refresh the whole table, like do a override, you can choose this particular option. You can also do the run with some advanced parameter, right? Run pipeline with table full refresh and all that. But let me run this pipeline just like this. Okay, I see I'm getting some error because I had already created this this tables already. So but a one particular type pipeline particular table should be managed by a single pipeline, right? So let me just change this to maybe branch right events, make this as event or something. That looks fine, right? So let me just run the pipeline now. So you might not need to do that because you are doing it from scratch, but I'm just mentioning this as a different table name. I see that it started, so it's doing the run. I can go there. So you see that this is got written. So you see that this is the streaming table, and it took like outputs is 145k. So I had already run this previously. So in the branch, like this particular volume, right? So in this particular volume there are a lot of data got written, so it just read everything and then it copied, then it returned to this particular streaming table, right? So this is the streaming table that you got. So you can go click on this, you can go to data, then you will see the data here, right? So this is the ingest time, like when we ran this particular thing. Okay, so as you see now your branch tables are loaded. This is the branch right event, but why did it created this table, right? To check this, you have something called as settings. Either you can click here, okay, or you can also click on this particular setting. This just use the same thing, right? So there are some pipeline setting. This talks about pipeline ID. If there's a pipeline mode, this is a trigger. Basically once you do run, or you can also use a workflow job to trigger this is a trigger mode. You also have a continuous mode, means if you want to run this continuously, then you'll be using that continuous mode. We'll be using that because this is a continuous job, but I'll showcase you that later. Okay, so and this is where you define the code assets. So this is the root folder and this is the source code. Source code means whenever you are writing any code for a Spark declarative pipeline, you want to mention this as a source folder, because we can create more folders, something like exploration, but anything that we write inside this will not be used to create the DAG around it, right? So then this is where you're defining the default location for data assets. So for example, you are mentioning that this is the default catalog and this is the schema. So whenever you are creating any table, you this will go to this particular schema, right? So let check that. So I'll go to the catalog. This is workspace. You'll have a real-time schema inside this, and this is where you will see the table, that branch right event, and if you hover over it, it will mention this is a streaming table, and every streaming table, or even for the matter every materialized view, will be backed by a streaming pipeline. So for example, you will see that current pipeline update status, that means that on March 30 it has been refreshed. So if you want to see the refresh detail, that means you will go to that pipeline, the declarative pipeline, which is taking care of this, right? So this is the pipeline that has been refreshing this streaming table, right? So I hope that makes sense. Now I'll go back to the job again. All right, now you might see that why did I create another folder like something like exploration? So idea for this multiply editor, or this new editor, is you do not need to leave this particular editor to do all your retail stuff. So for example, like my data has been loaded and I'm to do some exploration around it. So what I can do is, like, I can start creating some notebook. like maybe I can name this as a debug notebook. Right now I want to start writing the data, right? Reading the data. So select star from workspace dot real time dot branch write event. So I see all the data. Now I can do some debug. Maybe I'll see like if all the data is correctly loaded. If I want to do some other debugs, I can do that. And if you see that there will be one icon like this, right? What does this mean? That this file is excluded from the pipeline source code. So anytime that you run the pipeline, this file won't be included, right? Only the folder marked as pipeline source code that will be used. So if I just run it again, so it will remain the same, right? Like I can go back to here and I see that this is running, and I see that this is not included. Only the source is this branch write event that is getting loaded, right? I can also see some of the view streaming metrics. So any materialized view streaming table is we call it as a flow. So you will have flow attached to it. Then flow type is append. Currently it is append flow. So every data is getting appended, and you'll see other details also. You can also see if you're writing any expectation, that will see like while we are adding the expectation for the silver layer, we'll see all the expectation here. So it means that it has written all the records, right? It did not drop anything, correct? And you can also see the pipeline graph. So if you just click on this, and you can also do maximize, and you will see that this is the first graph, right now I have written. So I've run this in a different workspace, so you might see different number here, but yes, this is the output that you got, right? And once we start building this, you will see all this graph gets built automatically, right? So this is the lineage that you get out of the box. In Spark structure streaming, you will not get all this streaming, right? I hope that this makes sense. Now let's create the other folders as well, the other files as well. So for example, I'll go to our architecture. So we just did this, so we just read the data from here. Now we'll create one more streaming table, that is silver write events. This will have some filtration around this, and we'll also add some expectation, and we'll see how this expectation looks like. So for this, I'll create one more file. I'll name this as silver.py. This naming convention does not matter, you can name anything, but this is to just to signify that this is the silver layer code that I'm writing. So I'll have all the same imports whatever we just did, right? So we are importing the pipelines as declarative pipeline, and then some other SQL types we are doing, right? Now let's start creating the table. So I can name this as is data silver write events. So if you do not want to pass it, so you pass this table name here. So for example, in bronze.py, I've given the name as this one. So if you want to change the name, you can give the name, and if you do not want to change the name, you can just give the function name as the table name, whatever you want, right? So what I want in this layer, so I will do a return. So right, so first I want to read this branch tables, right? So this branch is a streaming table, like this particular table, and I want to read this table now, right? So but I want to read this in a stream fashion. Stream fashion means suppose today the 10 rows got added to the branch table, and even on the second trigger 15 records got added. So what I want to do, whenever I'm reading this, I want to read only the change data feed data, right? So first I'll read this 10, and in second time I'll read only this. I'll not read this again, right? So that's the incremental reading. To do that, in Spark declarative pipeline, you can do like spark dot read stream, then table. You can define the table name. So I have branch write event, if I'm not wrong. This is the event. Now basically we'll be creating some new columns, or you can say like we are doing some typecasting with the columns that is coming from branch write event. For example, if I go to branch.py, I'll see there is something called as no, I'll go to debug notebook. I'll see event time. Just a second, why is the event time? Yeah, so for example, this is coming as a string in event time, right? But I want to do some typecasting with timestamp for even for a event date. There is something called as event. Okay, so we'll be creating. So for example, for event time, which is a string column, we'll do some typecasting, right? Then we'll also calculate some of the other columns, like is this the day of the week, or if it is a weekend, or what's the final fare, and all of that sort, right? So we'll do some transformation on the silver layer. For example, first we want to do create one column, and we want to name this as a event underscore time. And what we want to do, we want to do some typecasting, right? So 2 times timestamp, then this is the event time. So whatever event time column that we're getting, we'll be doing some typecasting on top of it, right? So similarly for we want to do something called as event date. We want to create this column called as event date. Now I want to transform this, whatever the event time that I get, I want to transform this as a, yeah, this is correct. I'm very bad in typing the stuff. So whatever event time that we have, that is a string type. So I'm currently converting that as a event time on this as a timestamp, but whatever date we string we have, we are calculating this as a event date, right? So with that, we do have some other transformation also. I'll just copy paste all those things so that I don't waste time here. What we are doing is we are calculating the event date. So this is, we are calculating when did happen, event hour. We are doing also doing the event minutes, at what minute it happened, and if this is the day of the week, right, which day of the week it is. Then we are also calculating that is it a weekend, right? So if it is in between, so this function will take care of, like if it is in 1 or say 7, this is a weekend or it is false, right? We're calculating something called as final fare. So we are calculating this as double type, and base fare, distance kilometer, and duration minutes. And also we are calculating if it is cancelled. So I want to see if the status, so for example, if I go here, I'll see that there are different status: completed, cancelled by driver, cancelled by you will see also see cancelled by user. Yes. So if any of the status comes here, like cancelled by user, cancelled by driver, no driver found, then I'm naming this as a this is as is cancelled, right? So that will be cancelled one, right? So I hope this makes sense. And whenever you are reading something, if there are any issues happens on the Spark rate stream, then it creates a column called as rescue data. So I am dropping this for now because I do not need those column right now, right? So this is what you will get. Now I want to create this. So basically what happens is, I want to create this as a streaming table. So I'll decorate this with streaming table, and I can also add some comment here that what type of what type of table it is, right? So for example, I can write this comment as, this is a filter and reach right event. So for example, I can just give this comment, right? You can also add some table properties that this will be added in the table, right? Table property quality is equal to silver, so you can define this one. Now if you remember in the architecture, I talked about that we'll be adding some data quality checks or expectation, and in Spark pipeline, this is how you add the expectation. So you create one more decorator that is called expect. There are different expectation that you can add: expect all, or drop, expect or fail. So I'll be discussing one by one. For this particular video, let me explain what is this expect or drop. What it does, it checks for some of the columns. So for example, I can do like if, so I want to do some checks on if it is a valid ride ID or not, right? What's the condition of this? If ride ID, that is one of the column in this particular table, if it is not null, right, then that means that this is a valid id. If this is not valid id, so for example, for if I get some records, like if it is a null, right, in that case what I want to do is like I want to drop that particular row, right? So just think about how powerful this expectation is. Like if you do not want to use this expectation, you have to write your logic here, right? So you have to write all those filter logic. You have to filter right id is not null, then filter that record and do that. But you just get that out of the box just writing this one, right? Let me add some other column. You can add multiple expectations. So for example, I can do like expect or drop, right? I want to do like if it is a valid fare or not, right? For example, I want to say like if what does mean a valid fare? That valid fare is greater than 0, right? That means that if valid fare is less than or equal to 0, that means that I want to drop that records, right? Similarly, I can add more expectations. So I'll just copy paste the expectation that I want to write. So for example, I want to check if these are valid distance or not, if this is a valid rating or not, if it's a valid status. So you can do those checks here itself. You can check if it is a valid vehicle type in this one, then this is, so this is depends upon your business needs, what type of expectation or data quality checks that you want to write. Just think about how powerful it is. You are just writing the expectation, and Databricks or Spark declarative pipeline takes care of dropping those rows if this is not expected, right? So this is all I need to define this particular silver layer. So I'm not sure, there is one error is coming. What it is saying, invalid syntax Databricks. Why is that? Okay, let me just do a dry run. Let's see. Okay, I see the silver right events came into picture, right? Let me run this pipeline now. You can always check the graph pipeline, go to pipeline graph, and you will start seeing that the graph is coming into picture, right? So for example, I see that first our bronze write event should run, then there is streaming write silver, because there is a dependency between these two, right? And as you see how powerful it is to get the pipeline graph here itself, so you know all the dependencies. And I haven't defined the dependencies around here, right? So I haven't defined in silver py, I did not mention that okay, this particular table, or sorry, this particular table depends on upon this. So the engine takes care of this dependency management. So all I do is I just write the code, and everything else is taken care by Databricks engine, right? So like now let me show you few of the things. So first, if you see that I did not get any output for the first first particular streaming table. Why? Because I'm reading the incremental data, right? But I did not run my simulated job after once I loaded this table, right? So if I'm adding more data into the streaming into the volume, it will start reading the only the new records, right? That is the expected behavior, because I want to read only the incremental data that is getting added, right? For silver layer, you see that I got like 1.4 thousand records. That means that it read the data from the bronze right event, and I see there are 6 expectation got added, and you see that it says that view data quality. So if I click on this, I'll see all the expectation that I am adding, and I'm mentioning the action as drop. I'll get fail percentage. I'll also get like failed records. So if any of the records are not satisfied with this expectation, it will say that okay, fail is 1%. Then it will also say how many records are failed, right? You can also check only the failure only to see if you are good or not, right? So I see that everything is written 1.4 thousand records, and nothing got dropped, right? So from the UI itself, you'll have an idea of how many records got dropped or something like that. And this is something that this is from the UI, but you also get this as a system table. So I can discuss that later, but from a development perspective, this is very powerful to get this picture here itself, right? So I think we did discuss on the bronze, we also discuss on the silver. Now let's start creating this gold level materialized view one by one. So we'll do one by one and we'll create this as a view. So I'll go back here. Now I'll create different files for different like for this one we'll create a new file, for this one we'll create a new Python file, and we'll start building it. So let's first build this gold cancellation analysis, right? So I'll create a file. I'll name this as a golden cancellation analysis, and this is fine. This is the Python language. I'll do some imports, whatever the imports are required for. I'll just import the pipeline. I also import the functions. Now let's start creating the function. So everything here is mentioned as a function. So I want to name this as a gold can. This should be cancellation. And now I want to return some data. Like once this processing happens, I want to return some data. What I want to return, but because this is a materialized view, right? So I do not want to read this incrementally again. Means it is not a streaming table. So I'll not use spark.read stream.table. So I'll use just a normal spark.read, right? So for example, I'll do spark.read.table. Then what I want to do, because this will be connected to the silver table, so I'll do like silver write events. So I hope this is the table name. Yeah, this is the correct table name. So I'm writing this as a batch query, right? So whenever you write something like this will become a materialized view, correct? And then I want to do some filtration around it. I want to do like because this is, we're calculating the cancellation analysis. So I want to filter the records which are cancelled currently. So I can check like if column is cancelled equal to this is equal to true, right? So I want to filter this with this particular column. So any record which is like is cancel equal to true, I want to just pick that records, right? Now I want to do some group by. So on group by, I want to group by on event underscore date, right? I want to do group by on CT because I want to know for one particular day on the CT and on the status, right? And what is the cancellation reason, right? So I want to group by these 4 columns and I want to calculate some aggregations on top of it, right? So I will do some aggregates, right? So first I want to count how many write happened for that particular one, right? So I can name this as a alias is cancellation rate count, cancellation underscore count, right? I want to do some other aggregation, like I want to calculate. So I'll do some round function because I want to calculate some average around it. So there are some columns like search multiplier, right? So I want to calculate this average. I want to do by round and I want to give some alias around here. So this is the alias. So I can name this as a average search and cancel, right? So I hope this syntax is correct. I'm very bad with syntax. Then I'll do one with one more average, that is I want to calculate the distance kilometer. So I can do something like this, I guess. Not, I can name this as alias as average distance kilometer, right? And on top of that, I want to maybe suppose I want to do some order by also, right? I can do order by if dot column. I want to order by on cancellation count. This might not be required, but I'm just doing it just for the sake of doing the demo, but you do not need this, right? So I'm doing the describe sorry, as a descending order for that, right? So what did I do? I just read the table, I filter the data on this particular column, then I'm doing some groupings on event date, CT, status, cancellation reason, because I want to create a view around it, that what would be, so in this particular groups, how many writes happen, right? And how many, what is the search multiply happen for that. I also calculate what is the distance kilometer happen for this, right? So this is all it needs, right? You can also define this at a dp dot materialized view, right? You can name this as a materialized view. We can give some comment like, I think, let me just copy, I think this is the comment that you can give. So I want to calculate cancellation breakdown by city, status, and the reason for today, right? Actionable root cause view. So this is one of the materialized view I want to collect. Now I can just run this pipeline. You see that this is coming as a materialized view, right? So I can come here, I can, so you can click on all tables and you will see that this is the materialized view currently, right? This gold cancellation analysis, this is the materialized view, and in any materialized view you'll see some column as called as incrementalization. So this is the first time that we were writing this particular materialized view, so that's why it is calling as full compute. But if we start writing some data again, it will become as incrementalization, right? For example, to showcase you that, what I'll do is, like, first let's push some new data, right? So I'll go to the workflow that we have had for running the simulator job. Let me just run this job so that I'll start getting new records and I can show you that how this materialization is happening, right? Yeah, it started writing some data now. Now I can go back to the project, I can run the whole pipeline now, and you'll start seeing that it will start doing the incremental loading now. So I can see on the graph, so streaming table got loaded. I loaded like 120 records. On in silver also I got like 120 record. Now the materialized view is happening and you see it is showing as a incremental now. That means it is trying to do, you see that flow has been planned to be executed as a group aggregate, right? So you're doing some groupings around it and it identify what's the best strategy to do it incrementalization here. And that's why it is so powerful, right? In materialized, you just wrote like what you need, but in the second time when it run, engine will takes care of how do you incrementally update this particular table, right? So if you want to look for this particular table or materialized view, we can go to this debug notebook. Then I'll say like, okay, I want to see the data for this, so select star from workspace dot real time dot, this is the materialized view, right? So I see that for that event, for that city, the status cancellation reason, I see cancellation count, I can see the average search at cancel, I also see the average distance kilometer, right? And this is the view that is got created, and this will be updated incrementally from now. Now let me quickly just create the other incremental materialized view, right? So I'll just create one more file here. I'll name this as gold live KPIs. Now let me just copy paste this so that I don't waste your time in this. So basically this, you can make this as materialized view. So I want to create something like a operation KPIs, like live operation KPIs per day, writes, revenue, cancellation rate, active driver. So basically I'm reading the silver table, I'm doing group by on event date, then I'm calculating some aggregations, right? Aggregations of like, if the status is completed, then I want to create a status column, right? If it is cancel, I want to create a cancellation rate percentage. Similarly, what's the average fare in INR, right? And if this is like I want to calculate the column called as ingest time, right? What is the maximum ingest time? I want to make this as like what is the last updated column, right? So this is one of the materialized view you do it, right? So let me add other materialized view here. So I'll do that. I want to do some analysis on pickup demand, right? So this is one of the file that we have. So we can calculate this. This is materialized. I think I did the spelling mistake. I'll go back to this. This is the materialized view. So I want to do some write demand by pickup area and city for today. Identifies hot zones needing driver supply, right? So I want to calculate the hot zone here. So I'll just read the same silver table. I'll group on event date, city, pickup area and zone ID. I want to calculate what is the total number of rides, right? And I want to calculate the how many completed rides, right? I want to calculate what is the cancellation rate, because I want to create what is the cancellation percentage for this, right? So guys, I'm just explaining this explaining this code because I do not want to write this code. I am very sure that you know how to write this function, but this is just to give the idea like why this is done, right? Because I don't want to type this and waste your time here. So okay, so I want to calculate what is the cancelled rights. Then I want to calculate the cancellation rate percentage, right? So which is basically I want to calculate the sum of is cancelled then divided by what is the total number of right? That will give you a cancellation rate. I want to calculate the search multiplier, the average search multiplier, and also the what is the revenue in Indian rupees, right? So basically this will, like, whenever the status is completed, in that case you sum the final price, that will give you the revenue for this, right? So this is one of the view that we got created. Now I think we do have like three more materialized view. So I do have something called as gold underscore revenue. So basically why we are creating different views. So remember we talked about that we want to do some dashboarding around it, right? So this is the dashboard we want to calculate. So if I show you that rather than, you might think that why do I need this materialized view in the first place? I can directly connect from here to on the silver table, right? So this connection can be done. But if the connection can be done, you have to write this logic in the view itself, right? So every time your dashboard want to read some data, it will do all this calculation behind the scenes, right? And you have to take care of materializing it, you have to take care of incrementalizing it, right? So all those things you have to do, but reporting should be very fast, right? So what we're doing is using this materialized view, we are materializing this table itself in this particular layer so that this dashboarding will be quicker, right? So we can directly look for this materialized view, which is already incremental in nature. So any data that is getting added, it will be incrementalized in the materialized view, and Databricks dashboard can directly read from this materialized view without doing any aggregation, without doing any fancy stuff. This will be just reading stuff or maybe doing some checks and all that, right? But not doing any processing on the dashboard side, right? So it is to make the reporting quicker and it will feel like it's very snappier, right? So this is why we're creating multiple materialized view for it, right? So I want to do some other materialized view. I call this as gold underscore revenue per minute. We have the dashboard in place where it shows that in every minute how my revenue look like. So basically this is the materialized view which is taking care for that, right? So I'll calculate this. I'll just copy the code here. Right, so this is similar to that. We are reading the silver table. We are doing some filtration that I need only the last 60 minutes, right? And we are calculating the minute bucket, right? So we are calculating what's the minute bucket, and we are doing the group by on the minute bucket, then calculating some aggregations around it, right? So this is what we need for this. We'll be creating 3 more materialized view. Let me do it quickly. So I can name this as a gold right status breakdown dot py, and this will be very simple. This will be just like we are reading that, and we are grouping by event date and status, and we are just doing by what's the write count, right? So basically on that particular event date or the particular status, what is the how many writes happen, right? So basically the aggregation around it. So this will be very simple. And if you see that if I'm copying something, it is mentioned as db.table. But even if you mention db.table, and if you're just doing the spark read rather than doing spark.read stream, it will become as a materialized view. But this is always a good practice to make this as a like explicit, so that people understand, okay, this is the materialized view that I'm creating, right? So I'll do two more. I want to calculate what is the gold writes by city. So I want to calculate some aggregations on per city, how many writes are there or something like that, right? So this is one of the materialized view. I'll go copy this one. So I'm again reading that I'm doing by group by city because that's what I want to calculate. Then I want to do like how many total writes happen, what is the completed writes count, and what is the revenue earner, and what is the average fare, right? So per city wise I want to calculate some aggregations around it, right? So you can name this again materialized view. And the last is I want to calculate one materialized view that is called as gold top zones, right? I want to calculate like who is the top zone for that particular operation. So I'll just copy this, and I want to calculate for this particular day. So for today's date, right? So I am doing some filtration of on the event date that happened. I want to calculate read only the today's particular day. Then I want to calculate on the zone ID on the city. I want to do a group by. Then I want to create some aggregates around it. What is the total revenue, how many completed rides, what's the average fare, what's the average distance kilometer. So basically this will give you like, so for example I want to calculate something like top 10 zones by revenue for completed rides today, right? So for this type of queries I can just use this because I already have for today's on the zone ID and the city how I already have the aggregation, so I can use this particular table, right? So this will again be a materialized view. So this is all the materialized view I need. Then I can just do a run pipeline, and I hopefully I did not make any mistake, and you'll see the graph getting built, right? So if I just maximize this, you see that it is preparing new graph because you created a lot more materialized view. Then it will create the whole graph for you. So you see that it has prepared the graph for you. So you have the bronze ride events, it got like 1.3 thousand records. Then silver is like 1.3 thousand records. Now you see that it starts writing all the materialized view now, right? And depending upon what filter that you added, it will start creating those tables here, right? You see that the first one which was done previously, it shows as incremental, but the other thing is not incremental right now because these are all the new materialized view, right? So I hope that makes sense. So I hope that you understood on this particular one. So my idea was not to write everything by hand. My idea was to just explain you like how do you think about the streaming table, how do you think about materialized view. So think about materialized view as whenever you want to do some dashboarding, or if you want to serve this particular layer, right? So in Databricks or any Medallion architecture, gold layer is the serving layer. So basically if you are using maybe some APIs to read the data, so you want the pre-computed results to be materialized. You do not want to create some views, because if you create some views, it will do the processing again, right? So you suppose this is created as a view. So in that case, whenever someone is reading that view, it has to do all this group by, it has to do all the aggregation, then only you will get the result for it, right? But if you do the materialization means it has created this table. This is a physical table, but we name this as a materialized view. That means that if any data comes again, it will try to do the some incrementalization, right? So I hope this is makes sense. Now what we'll do is we have all the table that is required. So if I go to catalogs in workspace, in real time you have everything that we need, right? So this is all the streaming table. So for example, this is a streaming table, and this is a streaming table, and these are all the gold materialized view available. Now I have all the data in place. Now in the next section I'll be showcasing the most interesting part, and that is creating the dashboards itself, right? So I hope this was helpful. And what I'll recommend you is do it by yourself, right? Create this pipeline, start writing the code so that you understand. Okay, so for example, if you go to jobs and pipeline, if you open this, you have to do a edit pipeline, so that you open that in the editor itself. Now what I'll say is try writing more code. Maybe what you do is like on bronze or silver, maybe you can write more checks, right? Or maybe you can add some records which is not valid, right? So in the simulator job you can add some new records, like where the right IDs are null, so that you understand how this is working. So this is like you have to try a lot of things by yourself. This is how I learned. So maybe you can try that approach, run few things and do it by your hand, right? Don't just watch this video and you expect that you learn everything, right? That's not how it works. So do the practicals, run the pipeline, so that you will get a good idea around it. So right now our all the pipelines are done. So we are done with the ingestion, we are done with bronze layer, we are done with silver layer, we're done with gold layer. So everything is written by Spark declarative pipelines. Now we have to just create the dashboards again, right? And we have a bonus point that will automate all this creation using Databricks DApp templates, and we'll also use GitHub action to deploy it, right? But first let's create the dashboards. So now let's start creating the dashboard. To do it, like we call is AIBI dashboards. Go to dashboards, create new dashboards. So let's give this as name as Ride Analytics, something like Ride Analytics Executive Command Center, right? So there it happens to like you can add different pages in Databricks dashboard. So you can create like we'll create just one page and we'll add all the details here, right? So whenever you do that, first thing first, or it should be added with a serverless or a SQL warehouse, which is happen to be a serverless for in your workspace, but you can always choose your customize your default workspace, right? So you can do that. Now the first thing first is we have to add the data first. There are different ways to create it. First, you can always do add data source, and you can add the tables whichever is required. For example, for real time you can add the tables here. You can also upload some files, and you can use that to visualize something. But we'll use the second option, that is add data. We'll use the first option, which is create from SQL, because we have created the materialized view and we want to have some SQL in place, so that I'll have more flexibility around it, right? So I'll do create it with SQL. Now let me name this as this particular data set, name this as live KPI. So I want to have some numbers around the live KPI. So for example, I want to use, so select, I want to do like total. So I want to select star from the table that we have is, this is the table that we created, right? So workspace real-time gold live KPIs, and this is coming by because I do have, so if you remember, we have created the materialized view for this. So I'll go back to the jobs and pipeline. You see that we have created one materialized view called as gold live KPIs, which is having some APIs around it, and I want to use that. So I'll go back here. Now I'll not select everything. I want to select few columns, right? So for example, I want to select total revenue, right? I want to check what is the cancellation rate percentage, how many are active divers, right? What's the average of fare, right? and I want to do some calculation around it. What is the completed writes, right? So for example, I'll just copy this particular function because it's just easier to do that. So basically I'm calculating what is the completed write, so what is the total writes into what's the cancellation percentage. I'm calculating this as a complete write. So this type of calculation you can do on the data. So now this becomes a data. You can always check if you're getting the records for this or not. So I see that, okay, I have this revenue, what is the cancellation percentage, how many drivers are active, what's the average fare, and what is the completed rides, right? So I have all the data here. Now I can go back to the page, right? So this is the page. Now I want to create, maybe I can add some text box first, like, so for example, if I want to beautify this, I'll add some text box like this is the dashboard for this, right? So that it makes sense. So this is just to beautify this. Now I want to create some numbers around it. I want to show some numbers, whatever data that we got, right? I want to showcase all this number in the dashboard. So for example, I want to create some visualization around it. So you select this, add a visualization, you just select it here. Now I want to use the dataset as live KPI because we have created the datasets. Now what I want to do, first I want to create a counter. So basically the number that we have, you can select the visualization as counter, right? Now what I want to show, I want to show the value. So the value should be what is the total revenue, right? This is the number that I want to show. So this will come like this. Suppose you want the title, some title should be there, you can add this title, and you can also add some text here, right? So for example, I can add like what is the total revenue, and you can always resize this depending upon how do you like it, right? These things you can do. And now I want to add some more visualization, something like I want to add what is the completed writes, right? I'll still use the same use data sources, right? This is done, and I want to create this as a even counter again, right? Now on the value, it is like completed writes now. So I'll do completed writes. This comes as a number, and you can also add titles here. So I'll do it like this is the completed writes. I'll also add some new visualization and resize this. This will also be a counter, right? And the value should be, so I'm using the same KPI, value should be cancellation rate percentage, right? And this the cancellation rate. I'll also add few more visualization here. So I'll name this as this is event, this is also a counter. The value should be, I want to showcase the number like how many active drivers are there, right? So I will do like active drivers. So this is active drivers, not this one. Okay, sorry, I did some mistakes. So this is the cancellation rate, right? And this is the active drivers, right? So I can name this as active drivers, right? This is the active drivers you have, and you can add this. So I have like 2.76 thousand. I'm not sure like why this is just the simulated data, that's why the numbers are a little off, but you get the idea what we're trying to do, right? And I also want to add one more visualization here, right? That will also be a counter because this is the counter we want to do, but this time I want to add the value as what is the average fare price, right? So average fare rate, I want to calculate this. I want to name this as a average fare, so you can always filter this around, right? So So you see that how easy it is to create this dashboards here. So the first step is adding the data set, basically how you want to show this. So you already have this. Now it is just to show. So you just add a data set, you just add what visualization you need or what's the value you want to show, right? Now I want to create some new visualization here. So if you remember, we had a chart called as what's the revenue trend for last minute, but that is coming from a different data sets, right? So first we have to add the data set here. So I'll go back to data, I'll add new data set. So I can name this as, this data set should be revenue per minute. Now I'll just write the query. So select, maybe this is coming from workspace. So I'll just copy paste the table, is easier. So basically, so I'm getting this data from this materialized view. I'm just selecting what's the minute bucket, what's the revenue ENR, and how many completed rides happen. So we have already recalculated that, so you can just run this. So once this is done, that means that every minute you're calculating the individuals. If you see that this difference is 1 minute for every rows, and you have what's the revenue number, what's the completed rights. Now I'll go back to the dashboards again. I'll create one more visualization here, and this time I'll select this revenue per minute data sets, right? And I want to create an area visualization here, right? So on x-axis I'll have minute bucket because I want to show the area on minute buckets, and the y-axis I'll have the revenue number, right? So this is the revenue number I saw, right? So this is all you need, and you can add this. Why I'm not seeing the data now? Okay, this is the wrong one. So this should be minute bucket, minute, and y-axis should be, this is not revenue ENR. Okay, so I just saw the mistake. So basically whenever you add some x-axis and y-axis, so make sure that whenever you are doing some transform, so basically there are some transformation happening. So if we add all this, so it will be issue because ours is already transformed, so we can just choose none. Similar for revenue NR, you have to choose none here, right? So that will give you the result you want. So you see that I got the diagram, and what it is saying that every minute you will see the revenue numbers going up, going down, and all this graph is already there, right? Now I want to have some other visualization here. For that I have to create new data set. So I'll go to data now. I'll do like create from SQL. I want to create some function, some data set called as write status mix. So this will come from a different materialized view that is coming from gold write status background. So this is basically, if I just run this, I'll showcase you the data so that it makes more sense. So that means that every time you'll have a materialized view that will talk about what is the status for the rides and how many rides happen for that, right? So there are like this many completed, this is the cancelled by user, this is the cancelled by driver. You also see there are no driver found for this many instances, right? You can also show that diagram. So it is the same trail. I'll go here, I'll add this visualization, and right now it will come from write status mix. So make sure that you add the correct data set you want to visualize, and I want to create this as a pie chart, right? So the angle that you have, that will have like write underscore count, right? Then again this should be count, and the color that you have, that this is the status, right? So that means that you are adding different colors around it, and you can always choose which color you want for which particular palette, right? So this is also becoming your dashboard tutorial, but yes, you can do all those fancy stuff. So that means you got the diagram. So you see that this many completed, these are the no driver found. You also have see seen cancelled by user and also cancelled by driver. So it's very easy to do this dashboarding using AIBI dashboards, right? So I'll do some more data sets. So I'll create data here, data sources here. First, what I'll do is like, let me create all the data source I need here. Then I'll add all those visualization data. Okay. So first I need a data set called as CT performances. So CT performance is basically, you are just calling this. Let me run this so that it makes more sense. This is coming again for the materialized view. So for every city, what's the revenue number, right? And also I'll create one more data sets, create from SQL. I'll name this as a top revenue zones because we want to do the checks here. So I'll just collect here, I'll just run it, and this is again coming from gold to top zones. So don't worry, this dashboard, what I'm going to do is all these queries, while I do the CI/CD in place, you will see that how do you commit these dashboards in your GitHub, so that you'll have access to all this query itself. So don't worry about all this query now, right? So that means that every zone, every city, what's the total revenue, what's the completed rights, what the average price, right? Now I need two more data that I'll just create now. So I need cancellation reasons. So I need one data set called as cancellation reasons, right? So I'll just run this. This is coming from cancellation analysis. So you see that for every CT, what's the reason, what's the cancellation count, right? And I'll have one last data set that is pickup demand, right? And this is this query. I'll just run this. You'll have access to all this query, don't you worry. Okay. So I see for every city pickup area zone ID, how much total right, cancel rights, and what's the cancel rate percent. So I have all the data sets in need. Now let's quickly build the dashboards, right? So first, I need what's the revenue number it is happening for all the cities. So I'll just select this. I'll add new visualization here, and the source for this will be CT performance. So there is one data set as called a CT performance. I'll have this as a bar chart, that's fine. In x-axis I'll add the CT, so this is the CT. On the y-axis I'll have the revenue number. So you get the idea. So every city will have all the revenue in place. You can always add new title here. So I can name this as a what's my revenue by city, right? Similarly, I'll have one more chart called as revenue zones. So let me add one more visualization here. The data set should be top revenue zones, and the visualization should be this maybe, and this we can name this as a table, right? That's fine for you. And the columns is, if you want to, I think you should have add all, right? Let me see. Yeah, I think this is fine. We can add all the columns, so we'll have what's the completed right, total revenue, and all that stuff, right? And let me add some title. Title could be what is the top 10 revenue zones, right? I'm not sure if this is 10, 8, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, these are the 10 records, right? So that's how you can do, right? So now I want to do some drilling around we want to do some deep dive on the operation part, right? So let me just add a text first here. So I want to name this as a operation deep dive sections, right? So this is the operation deep dive. Now I want to add some visualization here, right? The first visualization will be what's the cancellation reasons by CT. So first thing first is you add the data set here. The data sets will be cancellation reasons. So this is the first data set. This will be a bar chart, that's fine. On the x-axis we'll have the reason. So you have the reason. On the y-axis you have the cancellation count, right? And also the color, that means you want to do like checks of city wise, so you can just add all the cities here, and this will be all you need. right? You can add the title here, so you can name this as cancellation reasons by city, right? So you can just do like this. So you see that you got the idea, right? So for Hyderabad, you have all the reasons mentioned here, and this you can check here, right? We'll add just one last section, that is area hotspot. So basically I'll add one more visualization here. I'll name this, so this will come from pickup demand. So this is the data set, so this is coming from pickup demand, and the visualization is, suppose I'll just name this as a table, right? And the columns could be, maybe I'll add all the columns here, right? So this will become, so basically if you remember in the starting I showed you regarding this dashboard. So this means that this particular area is having a lot of cancellation rate, right? So I can always add a title here. So always add a title please, or else it makes it very confusing to understand, right? So this is the dashboard. So you see that I got all the data that I need for me, and this is the dashboard that is coming in place, right? And you see how powerful it is to create this dashboards in EIBI, and how snappy it is, right? It's so fast and it looks really good. Now I can publish this dashboard, so I can do publish here. I can share data permissions, I can notify the viewers, I can copy the link. So let me just do a dashboards. I can give who has the access to this dashboard. So if it is like all workspace user or all account users, they can manage, edit, run, or view, right? So right now I think it got published. Yeah, it is already published. And one more thing you can do is like, if I go to view published, right, you can also add new schedules here, right? So currently you have to do this refresh schedule so that it gets refreshed every time. But if you want this to get refreshed automatically, because this would be a real-time dashboard, so you can always add a schedule here. So for example, I want to do like every minute. So this is how granular you can do. Every minute I want to refresh the schedule, right? So I can name this as a every minute. I can select what's the SQL warehouse I want to do. I want to also, if on the refresh, I can also mail this to some folks, right? So you can create notification and all those fancy stuff you can do. So you can just do like create here, and right now this will be running as a schedule. So every minute it will be scheduled, it will be refreshed, and you'll get all the new data here, right? So I hope this makes sense for you. Now um, I hope this will make sense for you. So now the dashboard part is done. Now the fun part is that what you have built everything by hand, right? So you have created all the pipelines. So this is the pipeline that you created. So you did a lot of simulation job creating manually. But how do you automate all this stuff? Uh, all this stuff, right? So this is where we'll be seeing how do you use Databricks asset bundles and how do you use GitHub action to automate all this stuff, right? So let's jump into the next section. Yeah, so what did you create so far? So we created, this is the dashboard job we created. Then we also created some of the jobs, right? One is the SDP job, one is the simulation job. And also if you see that I do have if I go back to the pipeline, that is the SDP pipeline, if I do edit pipeline here, and we have created a lot of artifacts here, right? So we're gonna need this all these artifacts in the git folder. So if you remember, we have used if we go to settings, then we have used the workspace, and this is basically the of git folder that we have, right? So this ride analytics project from scratch, right? Now if I go to git now, I'll see that all these files are added here, right? So first I'll do is like, so basically the idea is you are creating a git folder. So every artifacts you'll be keeping in the git folder, and you'll be creating some dApp templates, and also you'll be creating the CI/CD pipeline on top of it, right? First let me commit it. So there are different ways to do that. Either you can do it from here, or you can go to workspace. You'll see that it is a git folder, that's why this branch is coming up. So you can click on that branch, you can give some message, right? This is the workspace or all the SDP files are here, right? I'll do a commit and push. So you'll get this error, right? Because now Databricks does not have a idea of how do you connect from your account to GitHub, right? So that's why you have to configure the Git credentials first, right? So I'll go here. I'll go to view edit Git credentials. So it will add a Git integration here. So do a add Git credentials. You want to do with GitHub, so you can link the Git account here. And right now I have my GitHub is logged in here, but it might ask you to connect your Git, right? So it might ask you to select your Git account, then you could just do like authenticate and this will be done, right? So this is already done. Now I can go back to the workspace. I go back to the branch and I give some message committing again, right? Now it will be able to push the data, right? So this is done. Now all the files are already there. So if I go back to my project, so this is the repository, right? I'll see in the main branch I have the exploration notebook. I also have the transformation notebooks, right? Whatever I need currently. Now I do have the dashboard also, right? So how do you deploy the dashboards? You go back to this one, home, right? You go to dashboards. You select the dashboard first. Not this one, sorry. Select this one, right? You go to edit draft. So this is basically the published notebook, but you want to edit the draft first. Now click on this. You'll see an option called as commit to Git. So this is basically how do you commit this particular stuff, right? So do a commit to Git, and you can do like, you can always create a new Git folder, but you already have a Git folder in place, right? So I'll move to an existing Git folder. So I'll select this one, write analytic project from scratch. I'll create a new folder that I'll call this as a resources, because we'll be keeping more resources. We'll keep our DApp templates here. So this is the new resource that got created. I'll do a move, right? Now this is done. Now you see that this option called, right? So any changes that you do here, even that will be tracked by Git, and this is really very powerful, right? So now if you click on this main branch, you'll see that this is got added by a lv-.json, right? So Databricks dashboards get created like something like this .json. Now you can commit this, right? Commit the dashboard, right? So this is done. So this is all good. So now if I go back to your this one, if you refresh this, now you have the resources and you have the database JSON. And if you remember, we talked about that we have created different data sets. So see, you see that all these data sets are there. So you see that there's a live KPIs, there is revenue per minute, even the query, you see you'll get the queries here itself. So while you can always copy the query from here and you can do some changes on top of it, right? So for your reference, while you're doing the development purpose, you can always refer to this, right? So if you go back to the repo that I'll attach that. So this is the final repo that you will have, right? So you can always go to resources and you can always open this and you can get the query here while you're developing the dashboards, right? So this is for your reference, but we are doing everything from scratch. That's why we have created a new repo, right? That is a Write Analytic project from scratch. So now you have all the files that you need. Now what we'll do, like we'll copy this, we'll clone this in your local and we'll do some changes on top of it. I do have SSH keys configured, so I'm using SSH. If you don't have, just use the HTTPS. So I do have this. I'll go to my terminal. I'll do like git clone this one. So I have opened this in cursor, like you can use any any ID that you like. So this is the thing you have, right? You have resources, you have transformations. The first thing you have to do, we are now creating the Databricks asset bundle. So first thing first, you have to create something called as databricks.yaml. So you just create a file called as databricks.yaml, because this is required for Databricks templates to understand that how do you deploy these resources, right? So let me just copy paste few things so that it's just easier for me to explain. So I'm naming this as bundle as real-time data analytics. Then we are just using some variables. You might want to use this, or you might just ignore this, but few of the variables that you can use is, if you want to alert some email, you can add that email. And few of the things that we really need, that is the landing volume path, because we need this volume path. We also need a warehouse ID, right? Warehouse ID, if you remember that in resources, in the dashboards. So if I go to dashboard, so suppose this is the dashboard. Yeah, so it runs on a SQL warehouse, right? So it uses a SQL warehouse to run it, right? So if you want to do that, you have to select the warehouse here. So go to compute. This is the SQL warehouse, right? And in the connection details, you will see the SQL warehouse ID, right? So this will be the warehouse ID that you want to do, right? So you can come here and you can replace. You can go to your warehouse ID and you can replace this stuff, right? So this is the SQL warehouse ID that you have, and the default volume path remains the same. That's fine. Now you are including some resources. Right now I'm including only the YAML, so I'll be talking about what YAML files you need, but you do have the targets here, right, where you want to deploy this, right? So you can name this as mode equal to production, because you do not want some prefix to be added. Default equal to true, so anytime it runs, and this is where you will give the workspace ID, right? So you go back to this one, you just select the workspace ID here. So this is the workspace URL, so I'll just copy the workspace URL, and this is the workspace URL, and the root path, basically this is the placeholder you want to give, like where you want to deploy these files, right? But before that, we want to configure our Databricks CLI. So make sure that you have the Databricks CLI installed. So if you do not have that, you can use Databricks CLI download, right? So there are different ways to install it. If you are in Linux or Mac, you can use this, or if you're in Windows, you use this. So one you should have this as a command. So you should have Databricks, you should have Databricks CLI here, right? So let's configure the Databricks CLI now. How do you do that? Databricks configure, then apply this, move this. What it does, it configure the Databricks token. Now you select the host first, right? This is the host. Now I also need the personal token, so I'll go back to the workspace, right? I'll go to settings, I'll go to developer, I'll go to access token, I'll create a token here. So this token could be right, you can define the lifetime and API scope. Right now I'll do the all APIs as scope. You generate the token, get the token from here and go back, then do it, right? Now your Databricks configuration is done, right? Now I'll create some of the YAML files, right? So I'll go back to resources. So first thing first, you're gonna need something called a dashboard.yaml. So currently you have created this, right? You have created this JSON. So this is one of the JSON file, but you need a template file, right? So you need the dashboard. So there is dashboard.yaml. So you can create this file, and this is how it will look like. So this is the format for creating a dashboard with Databricks asset bundle. So you define the dashboards here, and you define the name, you define the display name that you need, and the file path, right? So this is basically the file path. Now this file path is write analytics executive command center lv-.json, right? And you also want to pass the warehouse ID. This is warehouse ID is coming from here, right? So this will be needed to create the dashboards. And what is the embed credential? If you want to embed credential, you can do embed equal to true, right? Now I'm gonna need one more pipeline that is called as so this is the dashboard, but you're gonna need a SDP pipeline, right? So you call this as a pipeline dot YAML. In you copy this path, right? So this is the, I'm just copying the default template that we have. So you can name this as a resource, and this is the pipeline. So this is the pipeline configuration, right? The pipeline name, you can name this a ride analytics pipeline. Serverless equal to true because you want to run this serverless. Continuous equal to true. If you remember, I talked about that you can always use triggered, but while we are doing the development, we'll run this in continuous because we want this live data to be there, right? And you can also define which catalog, which is a schema. So basically this is the default catalog a schema that you want to create. What's the root path and what is the library, right? So currently this is important. Currently we do not have source pipeline transformation, so we have directly as this. So basically this will be your root, right? Then you have directly the transformations, right? So you can just include this. So this is like the wildcard. So what it is saying is anything that is available in transformation, use this as a source file and create your stuff, right? And in the configurations, you can pass this key value pair. So this is the volume path, and this is coming from the variable again. So this is the variable that you are getting, right? So this is good. Channel is current or preview. Current is means whichever is in production. Preview, you do have features that is upcoming, but you do not use that in production. So you can always check that. You can always add some tags around for this. So all this is needed to create a pipeline. So this is very easy. You see that you just creating the YAML files and everything else will be created for you, right? Now to deploy this, I'll create a new profile. So first thing first, you want to do like Databricks bundle validate. So I see that I'm able to do the validation here. So I'm able to connect to this one. Let me just run this, right? Sorry, this is not run. So basically the command is vendor validate deploy, right? So you can always pass the target here, but by default target is 2. And we'll also do like /force because right now the dashboard is already created and we are using the same name, so it might fail. So you can just use Databricks bundle deploy equal to force, right? So let me just run this. Let's see if it is running. So right now we are not doing CI/CD with Databricks action or something. We're just trying to validate if the dashboards and if the pipeline is getting created or not. I see the deployment has been completed. Let me go to the workspace. Let's see. I'll go to first dashboard first. You see that this dashboards is deployed. So last modifies is date for, okay. This is the dashboards. I'll go to jobs and pipeline. I'll see that new pipeline has been created and it has already started working on, right? So it's waiting for resources and it will start writing the data for it. And this is something that is created by Database Asset Bundles, right? So you will get this particular error where it says that, okay, this table is already managed by pipeline, this one. A table can only be owned by one pipeline, right? Concurrent pipeline operations such as maintenance and full refresh will conflict each other. Please rename the table to proceed, right? So either you can change the table name, because if suppose a different pipeline is working on the same table, then it might have issues in what data is it updating, is it updating the state properly. So it's a strict checks that we have that only these tables, even if it is streaming table or materialized view, it should be managed by only one pipeline. To fix this, let's delete the older pipeline that we have. So this is the pipeline that we created previously, so we'll just delete it. But remember, if you delete this, all the underlining table will be deleted. That's okay because we'll be creating this again. So let me do this, right? So right now, so the table that pipeline got deleted. Now let's try this. Let's run this pipeline again. Now I see that it has started giving me the graph, like, and now it's starting to read this table and write this table accordingly. So now it will pass, it will work now. So this is how we did, right? So we created this pipeline, and this is done through database, through DAB, right? So if we try to do edit pipeline, it will say that this is created by declarative automation bundles, and now you cannot edit it. You can either do it on here, and you can also see we have created one more Databricks dashboards, right? So all these are automated now. But what he did was, like, we use Databricks bundle deploy force here, right? So basically we're doing from CLI, but this is something you'll not do in production, right? In production you want some GitHub actions to be created so that you can do that. How do you do that? First, let's create a folder called as maybe .github, and we'll name this as workflows, right? And we'll create some file called as deploy dev.yaml. So this is required for GitHub action to know. So think about like how we did for Databricks YAML for resources. In Databricks GitHub you do something called as GitHub actions workflow YAML, right? So let me copy one of the code and let me paste it here. Let me explain you what it does, and all the references you can get from the GitHub link that I have posted. I'll be adding in the comment section, right? So it's a, what it is doing is I'm adding a stage call, adding action call is deploy to dev. I'm doing that if any push happens on this main branch. So currently we are working with the main branch. So if any push happens, you just deploy this, right? So you just run this job. So this has like two different stages. One is we are having some checkout steps, right? So this is basically we'll be checking in GitHub action need this code in their repo, right? Then we are setting up the Python, we are installing the Databricks CLI, we are installing the Databricks CLI, then we are also installing the Database Asset Bundle CLI. Then we are doing the bundle validate, and if you remember, this is the command that we do, right? Databricks bundle validate, and we are passing the target. So currently we do have only one target, and on the environment we'll be using two secrets, right? One is the Databricks host and one is the Databricks token, right? We'll be setting this in GitHub, and once this is validated, we are checking, we are doing the bundle deployment, right? So this is the force we are doing in case if there are any overrides. So we are going with force, because if there are any dashboard exists, so we'll use force to deploy this again, right? And the same, it will use the Databricks host token, right? So this is the way to create a GitHub action. So let me push these changes in GitHub, right? So I'll go here. So this is, I'll stage everything. Then this is what we did. We did the dab and GitHub actions, right? And let me push all the changes. Okay, I just had some hiccups to push the changes to GitHub, because I was using a SSH key, so I had to configure few things, and right now it is being pushed. But if you're using HTTPS, you should not have any issues to do that. So if you go to your project, now you'll see that you'll have something like this, and if you go to actions, you'll see that you'll have a actions called a deploy to dev, but this is failing. So if you search on this, so this is basically why this name is coming up, because if you go back to your deploy dev, so you will see that this is the name that you're giving, right? So basically this name will be taken care by in the GitHub actions. So if you click on this, you will see there issue is coming up, that it will say that cannot configure default credentials, right? And you remember we have defined some variables around it. So if I go to dev, you'll see there are two things. One is Databricks host and one is Databricks token. So we'll configure this one now. Okay, let's go back to your Databricks actions. We'll go to settings. We'll go to, maybe there is a secret and variable, then go to actions. You'll see that you can pass repository secrets. So create a repository secret at Databricks host, and this is basically the Databricks host. You can copy from here right? So this is the host, and you have something called a Databricks token, right? So I'll create one more token. I haven't copied the token, so I'll create one more token again. So I'll go back to settings, I'll go to developer, I'll create one more token. So this, you can mention this as this is GitHub actions, right? So let me copy this. Don't worry, I'll delete all this tokens, right? So I'll go back to this, I'll create this token, and now I'll go back to actions again. I'll go, this is the action. Now I can do the rerun the jobs, right? So I'll do the rerun again. Let's see if it is successful now. So it will start running all the stages now. So you see that it validated the workspace, and it also deployed to dev, right? So this is successful now. So you see that how easy it is to deploy something with Databricks bundles, and also like how do you automate that from GitHub actions. Now the pipeline is running in if you go to setting, you will see that pipeline is running continuous mode. So as soon as your data, so you see that right now it is waiting, it is running, but it is waiting for the data to come, right? So once you have the data, suppose if I run this job now, this is a simulation job which is writing the data to the volume. Once it starts reading it, so let me see, it is still pending. So once it starts writing the data, you will see that this will start picking up the data and it will run it. So that's why with this, with all this, you have built a real-time pipeline which gets the data from volume. It creates different streaming table, it creates some different materialized view, and it also creates a dashboards, right? So this is how you're gonna create an end-to-end project with Databricks. And also you have seen the power of Spark declarative pipelines. So I hope that you enjoyed this particular video. So we have seen like how do we build the whole thing from ingestion, bronze, silver layer, gold layer, how do you create the dashboard around it, and how do you create a whole pipeline using Spark declarative pipelines. And also we have seen how do you create the dashboards from scratch, right? So guys, this takes a lot of time and lot of effort to create this type of video for you, and I have seen a very positive feedback for this end-to-end tutorial. So I really appreciate if you like, comment, and share this video with your friends and with your colleagues in LinkedIn, or maybe wherever you feel like this will be helpful for other folks. Feel free to share it, and let me know in the comment section what are the different types of video you'd like to see in this particular channel. I'll really work on those type of ideas, right? So with this, I'll end this video and see you in the next one.